Hi everyone, in today's lesson we're going to talk about the quadratic formula. The purpose of the quadratic formula is to find the roots of a quadratic equation when the equation itself cannot be factored. So here are the steps that we need to follow every time we're using this quadratic formula. You have to first set the equation equal to 0, write down the values for a, b, and c, and substitute and then solve. Now, I believe this first example can actually be factored, so let's just see what the answers are supposed to be if we use the quadratic formula. So we add multiply, and I think this should give you x minus 4, x minus 2. So our answers should be positive 4 and positive 2. Now, I know you can factor this, and many people would choose to use that method, but the directions here are saying using the quadratic formula. So let's do that. So first things first, what are my a, b, and c values? Remember, the quadratic equation is ax squared plus bx plus c. So if I have x squared minus 6x plus 8, it's very easy to see what a, b, and c are. You could technically put a 1 in front there. So a is 1, b is negative 6, and c is 8. So let's first start by writing down the equation. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So whenever we substitute, we're going to substitute with parentheses. So it's x equals negative something plus or minus the square root of something squared minus 4 times something all over 2 times something. So what goes in here is the b value. So b happens to be a negative 6. Again, another b goes in here. The a value goes here, and the c value goes here. So a is 1, and c is 8. And again, the a value is 1. So the first step is substitute everything with parentheses. And then we keep going. So x equals, what is a negative 6? You should be telling me 6 plus or minus the square root of something all over 2. Now please take a moment, pause the video, put this into the calculator just the way you see it without the radical. Do not put the radical into the calculator. Okay? I'm even going to write it. Do not put radical in the calculator. Okay? Just put what is here and then hit resume when you've done so. Okay, you should have gotten 4. So now it's time to simplify this. Well, the square root of 4 is something I can simplify. So this is x equals 6 plus or minus 2 over 2, because the square root of 4 is 2. So now what this means, this is 6 plus 2 over 2, or 6 minus 2 over 2. So let's write that out. 6 plus 2 over 2, or 6 minus 2 over 2. So 6 plus 2 is 8. 8 divided by 2 is 4. 6 minus 2 is 4. 4 divided by 2 is 2. So look here, my two roots just so happen to be x equals 2 and x equals 4, same as they were supposed to be here. So where it says the roots are, we could write the roots are real, because there's no imaginary numbers, rational, because they came out to be pretty, and unequal. They're not equal to each other. The two roots are x equals 4 and x equals 2. Again, they're real numbers, rational because they came out nice and pretty, nice whole numbers, and they're unequal because they're obviously not equal to each other. Alright, let's look at example number 2. The first problem that I see here is that this equation is not equal to 0. So let's do that. We've got 2x squared plus 40x. We could add the 80 and set it equal to 0. Okay, so your first instinct might be to factor, and that's okay. I actually would do that as well. I would see a 2 and I could take it out. So I've got x squared plus 20x plus 40. Now by factoring out this 2, it makes our life a lot easier when we use the quadratic formula. So let's do a t-chart here. 2 equals 0. Does that make any sense? No, we're going to reject that. Now I took out that 2 because now I can factor this trinomial much easier. I actually cannot factor it because I won't find a pair that multiplies to 40 that adds to 20. So what I'm going to do is use the quadratic formula, where my a is 1, my b is 20, and my c is 40. Okay, so x equals negative something, plus or minus, square root of b squared minus 4ac all over 2a. Again, placeholders. So x equals. So what is my a, b, and c? So again, it goes negative b, so that's 20, b squared, 4ac, all over 2a. So negative 20 is simply negative 20, plus or minus the square root of something over 2. Now again, do not put the radical in the calculator, just put this in and hit resume once you've done so. Okay, you should have gotten 240. Alright, now we need to simplify that radical 240 over here. So I'm going to write it on the side, and I want to find what two numbers multiply such that one of them is a perfect square. Remember, you could put in the y equals 240 divided by x and find the factors. So take a minute, pause the video, and do that. Okay, I got 16 and 15. So 16 and 15, so 4 rad 15. So I've got x equals negative 20 plus or minus 4 rad 15 all over 2. Now if you recall, I can divide this by 2 and this by 2. Again, never touching that inside number. So we get x equals negative 10 plus or minus 2 rad 15. And these are your two answers. Now, there's really no need for you to separate them like I did here and here, because if I were to separate them, it would just be this. X equals negative 10 plus 2 rad 15, and x equals negative 10 minus 2 rad 15. So you don't really have to do that. But what kind of roots are these? They're still real, because again, we still have no imaginary numbers. This time they're going to be irrational because they're not so pretty. We've got ourselves ugly radicals over here. And they are unequal to each other. If you put them in the calculator, you would get two different decimals, this one and this one. Okay, let's move on to the next page. Okay, what I'd like you to do now is look at example number 3. What do you notice right away? That's the first issue. I actually don't like that there's leading coefficient to be negative. You could either take out a GCF of negative 1, or you could actually add everything to the other side and make it positive. So I'm going to add everything to this side, so my leading coefficient is positive. So 0 equals x squared plus 2x plus 5. So now what I would like you to do, now that this is nicely set up, and that this one is nicely set up, I would like you to plug into the quadratic formula and see if you can simplify them, and hit resume when you're finished. Okay, here are your answers so far. Okay, if you need to pause the video and copy this down, please do, but this is what I got so far before I simplified anything. Okay, so now I want to talk about this. There's a negative under that radical, so we have to break this up. So first thing we want to do is take out the I. So this should be x equals negative 2 plus or minus I rad 16 over 2. Now the square root of 16 you should be telling me is 4. So this could be x equals negative 2 plus or minus 4i over 2. And I can actually divide this by 2 and this by 2. So I can get x equals negative 1 plus or minus 2i. Now, what do you notice about these roots? I had a negative under the radical. I had to take it out and make it an I. So the roots are simply imaginary. That's all you have to write, that we have imaginary roots. Okay, now this second problem over here, I don't even think I was able to break up that 93. I tried, and I couldn't really find any factors that had perfect squares. So that really means 93 is it. So these are your answers. That was a nice one. So these roots, what are they? They're real, because I don't have a negative under the radical. They're irrational, because they're ugly. Ugly radicals that can't be simplified. And they're unequal. So if you even wanted to write them out, it would be x equals negative 7 plus rad 93 over 2, or x equals negative 7 minus rad 93 over 2. Alright, that's about it with the quadratic formula. Please make sure you star things that were difficult and ask us in class tomorrow. Thanks.